Hey YouTube, welcome again. Today we have the third part of our system design fundamentals. We talk about today about scaling. Basically, if you remember this design that we have created, if you're not familiar with it, I suggest that you see the last two videos so you'll understand anything. However, I will make a quick walkthrough. So basically, it is right now what we have created is a single server that has a single server setup that has using database. The client access database access the web server by its IP address, and the client get the IP address from a DNS service. It just send it to the domain name, and the DNS service send to the client the IP address, and the client connect with the web server with HTTP protocol, and the web server has the privilege to get to write to read and write data from the database, and it will get after the client sends a request to the web server. The web server will get the needed data from the database and send it back in the response into the actual client. And we talked about SQL and NoSQL and which one we should use. We said that SQL is by default we go through SQL unless because of the it's been there forever. It's quite fast. It's easy to make a complex query with them. We have an ACID transaction, so we'll make sure the consistency is right. And if we have NoSQL, also we could use NoSQL if our data if we had a huge amount of data. If you are not sure about the structure, basically if we need availability, if our application needs really low latency. So this is what we have talked in the last two videos, although I suggest that you have to see them first. Today we talk about the scaling. So let's say that we had multiple clients. Okay, let's say that we had multiple clients. Okay, and we no delete. Let's say that we had copy, paste, and let's say and the multiple clients of let's delete this. And the multiple clients, actually it takes it send the request to the server. Okay, and let's add more, so it will really look a lot. Okay, so yeah, let's just delete. I guess we don't need this one. Okay, so let's say that we have a lot of servers, a lot of clients that send the request to the server, and also they send it to the DNS first, and the DNS send them the IP address, but we just make it like that to make it easier for us to understand. And let's say that our server doesn't have a capacity to handle all of this load. So how we can solve this problem is that, okay, we need to scale. So we have basically two solutions. It's the first one. It will be something called let's just vertical scaling and horizontal scaling. Okay, and let's talk about what each of one of them means. So basically, vertical scaling includes adding more resources such as a CPU and RAM storage to a single server, this server basically, in order to increase its capacity and for handling more loads basically, or increasing the performance. And it's a great strategy for small and mid-size applications basically. And basically the pros and cons of this one is that first it's quite easy to implement. Okay, the cons is that each server has its own limit. So basically, if we add a CPU and if we add a RAM and so on and so forth, yeah, we can't add them forever. They have limits. And the last problem is that we have a single point of failure. We don't we if our web server just for some reason just for some reason basically had a problem, like for some reason this one get cancelled, or like find failure, okay, all the application is basically screwed. Basically, we can't do anything about it. So this is the basically the vertical scaling. And let's talk about now about the horizontal scaling, because we will use it a lot basically in the upcoming, in each system design interview. Not each, but most of them we will ask about work with horizontal scaling or vertical scaling, things like that. So basically, horizontal scaling, it's in other hand includes adding more nodes. So basically, I have this one. I have this server. Yo, that's a cheap. Okay. So, okay, they're just so basically the horizontal scaling on the other hand, it's that we are adding more nodes. So basically we are adding more servers, okay, to the system in order to distribute the workload across multiple machines. And in this approach, each node or each server typically could has smaller set of resources than the single node. Maybe they are not have the biggest RAM as a single node. However, the overall capacity of the system is increased by very far. Actually, it can handle tons of different loads. And by adding more nodes to handle increased loads, it's make our life way more easier when it comes to handling more nodes. And actually, when one of the one of them failed, the other ones continue working. So we make sure that we have a big availability, and it's a quite very it's very hard to make our application unavailable basically. And one of the examples that we use, we have a cluster, so we create multiple servers to make sure that our cluster is available all the time. And for this example, also for our example, so basically we have right now 4 web servers. So basically we will try to sorry. So basically I just yeah, and let's delete this one. And yeah, let's put this one here, and let's put them here. And basically, by adding this one right now, that we can just increase the oh, basically, and let's just do this here also. Basically, by adding this one that you can see right now, let's just scroll out just to make sure that you see the full picture. By adding this one, that you make sure that all of our clients, of course, all of our servers is connecting to the database. All of them are connected to the database, but I will not add all of the rows, so it will be quite hard to calculate, to see them, actually to present everything. But basically, but by horizontal scaling, the we have right now, we can, if you can see right now, it's way more easier for us to handle a lot of load performance. And one of our servers, for this example, been deleted, has something, the other servers can take its request and can send back the response to the other, basically to the other applications, basically. So this is the way that we could solve this one specifically.